So we got 5x minus 9 is less than or equal to 4x plus 3. So same old game as far as this problem is concerned. There's not going to be anything different. We got a less than or equal to, which means we're going to see what's going to happen. It just means that instead of being one number, it's a whole bunch of numbers that are less than or equal to 12. So first thing is they subtract the 4x from this side, from the right side, and then it's going here, and then 5x minus 4x is just x. Then there's a negative 9 here. We're going to bring that over here. So what happened is they're adding 9. So these are going, so that's x is less than or equal to 12. Now, a lot of people are used to seeing this where a filled in dot means that it includes that number, and if it's a circle, it doesn't include that number. All right, I want to show you a little bit on the next sheet, not quite yet, but when we start doing some of the problems at least, I'll show you how to use these things. A parentheses and a bracket are more useful, and you don't have to remember as much if you just go with those, because you got to do your interval notation. But if you just use, instead of that filled in circle, you use a bracket, that means the same thing. So what this is saying is that the solutions to this inequality are anything from way, way down to negative infinity, all the way up to including 12. And you can tell that just from looking at that right there. That's what that means. All right, 2 times x minus 4 minus 5 is greater than or equal to 4 times x plus 3 minus 13. Two distributions, 2 times x is 2x, 2 times negative 4 is negative 8, bring down the negative 5, and then 4 times x plus 3 is 4x, and then 4 times 3 is 12, and then negative 13 comes down. Combine anything that's alike, we got a negative 8, negative 5 is negative 13, 12, take away 13 is negative 1. So at that point, we've got pretty much where we can just now work on either side of the inequality. So the first thing is get rid of the negative 13 by adding it to both sides. So negative 1 plus 13 is 12. That leaves us with a negative 2x is greater than or equal to 12. Now, here's where the problem comes in. All right. If we've got an inequality, in other words, we've got an arrow pointing, that's what we call a greater than sign. The equal sign isn't a factor here. That's not affected by it because the equal sign is really just going both ways. But the inequality is pointing to the right here. Well, in order to eliminate that negative 2, we're going to do just the same things that we've did when we're solving equations. We're going to divide by negative 2 both sides. But what it happens is it turns that inequality around. So therefore, when we have negative 2 over 2, negative 2 is just plain old x less than or equal to negative 6. So that means anything from negative 6 all the way down to infinity. This interval notation is the same thing. It just means negative infinity all the way up to negative 6. And that
Professor Cruz,
bracket means it includes that. What you got?
why are we reversing the sign again? Is it because we're dividing it after
We're multiplying by a negative number. So what that does, if you got a number line, see if I can find something to kind of show you. So remember, I'll tell you what, this is going to be a good one. All right. So this right here is essentially a mirror image, the negative and the positive numbers around 0. So let's just say that if we take 4 and multiply it by a negative number, that puts us down here. So it flips things around. So that's why we have to do it in order for it to still stay true.
Okay, so we're associating it with the number line.
Yeah, that's what it
Okay.
is, because if x is greater than -4, and then we multiply it by a negative number, then that means that x would have to be less than -4. And so I'll try to point out when we graph some of these, because I know that it's kind of a hard concept, but that's what's happening. It's a mirror image. So when you multiply a positive number by a negative number, you essentially jump on the other side of the negative
Yes,
sign.
that makes sense. I
Yeah.
understand it that way.
Okay. All right. So let's go back. All right. Now, well, I'm going to put those problems on there, and y'all go ahead and work on those, and then I'll do a little bit of housekeeping here, and then I'll come through and solve some of these. So try 1 and 2. Okay. So on these, it's really pretty easy, right? Because there's not a whole lot to do. So this one right here, we're treating them separate, okay? Hold on a second.
So that should be X.
Hold on a second. Let me go back up. What was on this first page? Okay, you know what? I'm in the wrong one. That's not the one I was wanting to show you. Here we are. I was in the wrong spot. I'm sorry. That's the next lesson. So this is where we should be at. I'm sorry. Yeah, we're not into those double ones yet. The double ones are just doing 2 of them. But this is the ones I wanted to do. So try to get 1 through 4, and then I'll start going through in a minute. All right. So this one is pretty simple. The only thing that's isolating, keeping the x from being by itself is that 5. So I'm going to plus 5 to both sides. So these are gone, and you have x is greater than or equal to 14. Okay. Now I want to kind of show you when you got an equal sign underneath there, that means, of course, equal to. If you didn't have an equal sign underneath that means that it goes right up to that number and never gets there. So what are we going to do to graph this? All right. We're going to, first of all, I'm going to put just a number here, 14. Oh, I'm not going to put it right there. Back up. So 14 be, let's set it right here, and let's this be something on the upside 20, since it's going to that side. Now, what I'm going to do here, You can put a circle there, that's fine. But if you do it this way, then you don't have to remember, know the different symbols for the interval notation. So that's a bracket. And then we're going to just make a line that goes out there and keeps going. So that's x is greater than or equal to 14. The bracket means it includes the 14, and the arrow there in the positive direction means that it's going on and on and on and on forever, essentially, because there's always something greater than a number. It's always got something greater than it. Now, what they call the interval notation is simply taking that same symbol.
And that's going to be infinity, right?
Yes, and that's what I'm going to put right here. So for the interval notation, this is what it looks like. It really very much mimics the number line thing, especially if you use the same symbols. Notice that in infinity, whether it's a positive or negative infinity, always takes the parentheses, and that makes perfect sense because you would never be able to get to infinity. It's an always getting there type thing, and that's what that parentheses mean. So that means starting at 14, including 14, all the way up to infinity.
Mr. Cruz, I'm sorry, what's the name of this lesson again? The name of the chapter?
It's called inequality, solving inequalities.
Solving inequalities. Thank you.
See, solving linear inequalities. That's the formal name, solving linear inequalities.
Thank you.
All right. Now, what about that next one? Anybody come up with anything on that one?
X is less than negative 11.
Yeah, that sounds right. So we're going to subtract 5 from both sides. X is less than negative 11. Now, this is different now. It doesn't have the equal sign. So when we make that line, all right, and like I said, it's all a matter of just giving some perspective. Negative 11, I'm going to let that be right here since we're going in that other direction. And down here would be like maybe negative 15. It doesn't matter what you put down there. But I'm just going to put something just to give it some perspective. So anything less than negative 11 is going to be a solution to this. So what I'm going to do is I'm going to put a parenthesis there. And then my line is going all the way down to negative infinity. That's why my interval notation looks like this. And notice on this side, it never gets to negative 11. That's why it's got a parenthesis.
Mr. Cruz.
Mm-hmm.
So we use the bracket when there's the equal sign and the parentheses when there's no equal sign, right?
Exactly. The equal sign, and the bracket means that it also includes that number. But if it's a parentheses, it means that it goes right up to it. It never gets there. It does not include the number itself. All right. Well, let me try to show you something. You can solve this one of two ways, but let me show you. I'm going to just do it real easy wise. And so this means negative 10 is less than or equal to x. Now, if you had done it by bringing the x over there and having a negative x, and then bringing, adding the 6, and then you would have a positive 10, well, you would have to multiply by negative 1. But you know what? When you did that, you would end up with this. Oops. These two things are exactly the same thing, because notice I've heard people think of this like as a little alligator mouth. and it's facing towards the X, the pointer is going to the -10. So if we had solved it by introducing that negative multiplier, this is what we would have. And these two things are the same thing. The pointer is pointing towards the -10 in both cases. So then this is so let's say -10 would be right about here, let's say, and then this would be, let's just say 0 is up here somewhere. So it includes -11, but I'm sorry, -10. Oh, this is supposed to be 10, I'm sorry. -10, hence the bracket. And then we're just going all the way up to infinity there. All right, so the interval notation, we just bring that symbol down. And then the arrow means it's going in that direction to infinity. All right, number 4. What would you do with that one?
You're gonna multiply by the reciprocal.
All right, great. I love to hear that.
On both sides, of course. And my answer is X is greater than or equal to -15.
All right, that's all right. So let's go ahead and do that. I'll go work through it. But so we're going to take 2/3 X, multiply by 3/2, and we also got to multiply over here. There's no negative numbers involved on the multiply, so we don't have to change the sign yet. Okay, so these are just going to basically be 1. That's why we did it. So then that's right, -15. Good. And then, as I said, is the, so this basically just ends up being this. Right there. The graph is the same thing. All right, any questions about those?
None.
So, Mr. Cruz. So anytime it's a fraction in there, you always multiply by the reciprocal.
How else you gonna get how else you gonna get it as 1? That's the only way to do it.
Okay, gotcha.
That's what the problem that a lot of students run into is they so used to that they just divide by the number in front.
That's what I'm saying. Yeah.
They don't realize that that's the same thing as multiplying by the reciprocal. Division is defined as multiplying by the reciprocal. But if you put where to take and write that as such here, 2/3 with another 2/3 under it, it gets really complicated looking. So this is the easy way to do it. But yeah, you're always multiplying by the reciprocal.
Okay.
It's just that if it's a whole number, it's real easy to just, put that number underneath and divide it. Okay, start heading down to these. These are the ones where you got, going to start having some negative ones, I think.
I got -3.
All right, -3 what?
-3x is greater
Yeah,
than
but what's the solution?
x.
-3 with the infinity.
Okay, so once we introduce that multiplier -4, then this turns around in this direction. So we've got x is less than or equal to -3. Once we introduce a multiplier or a divisor, it's the same thing. Like I said, it's division is multiplication by the reciprocal. Then it turns that around. See, it's no longer greater than or equal to, it's less than or equal to. And it's now going in the other direction. That's a bracket there. All right, what about this next one?
I got -12.
Well, but there's more than that. You got to have the sign. What is it?
X is greater than -12.
Okay, see, that's important because we're not looking for just one answer. We're looking for that inequality answer, which is going to be a whole range of numbers. But anyway, let's do this. Get rid of that one, and that's just going to leave a nice 1x over here. So 7 plus x is greater than -5. And then -7, -7. So x is greater than -12. So the interval notation looks like this. Okay. In other words, it's everything from -12 almost, not including -12, all the way up to infinity. All right, what happens on this? Let's see. Now, this is one, like I said, is just like with an equation, you can put the x's on either side you want and put the y's on whatever side and the numbers on whatever side you want. So I'm going to put right here to save some room. So that's 10. So that's dividing by 10 gives us 10. Now, let's just say that instead of doing it like that, I'm going to go over here and just kind of write crossways. To just show you that the rules for math are consistent and that you don't really have to worry about what side you choose to isolate on. Let's say instead of putting my variables on the right like I did over there, I do it over here. All right, and then I'm on to +2. Wait a minute, hold on a second. No, -8. So these are going and those are going. So I got -10x is less than or equal to -10. All right, now that looks completely different than this, right? Same numbers in a way, but watch what's going to happen. When we divide by that -10, then what happens is we have to change that thing around. So this is now positive x. Oops, what was it I did here? Oh, yes, 1. That should be 1. I apologize. It should be 1. Because it's 10 divided by 10, right? So let me fix that. So that was 1 is less than or equal to 6. Or x is greater than or equal to 1. These two things are exactly the same thing because to what side is the pointer pointing on each case? They're both pointing. That's the pointer. They're both pointing towards the 1. And the opened end, the mouth end, is towards the x. So these two things are the same thing. And that's what I'm saying is, what side you work on does not matter as far as isolating your x. You're still going to have the same thing. The reason why, if we had switched that sign around though, then it would not be the same because that's why we have to do it. And you see those two things match. So in any event, that's 1 to infinity. Y'all still there? I keep hearing a lot of activity.
Yes.
Like
Yes.
people going off and coming back and bings and boops and stuff. I don't know what's going on. All right. Try these next 3. These are ones that, I mean, they're using everything. They're putting together the distribution, and then you're going to have to do some collection and all. Okay, what happens on number 8?
You gotta multiply 3 times 2 and it'll be 6x
Yep.
minus 15.
Yeah, 3 times that, so it's -15. And then the right side stays the same
Stays the same.
because there's nothing multiplying that. And now we can just collect.
Mhm.
Now, again, it doesn't matter what side you collect your x's on, as long as you apply, if you end up with a negative variable, though, it's gonna turn around. So if we do proceed putting it on the left, see, that's going to make a -2x. And then this is going to be plus 15. Oops. And plus 15. So this is -2x. So these are gone. And that's 10, right? Positive 10, negative 5 plus 15. Now, see that? Because we're going to divide by that negative 2, you got to turn it around. You got to turn it around. Some people will do it as soon as they introduce a negative number there, but I didn't want to turn it around. And since I already, because technically that's an extra step. I mean, that's 2 steps there. So is that right?
Yeah, that's what I got.
Yes.
Okay.
Yeah, I got it too.
X is less than negative 5. So again, the interval notation, it's the arrow is going in the negative direction. So that's negative infinity. And then it's coming up to and including negative 5. So we use the bracket. Okay. How about that next one?
And so, Mr. Cruz, so the rule is when you have it a negative number, you got to change the sign.
In front of the X.
Okay, when it's negative in front of
Doesn't matter about the other side. But if it's an X, you've got to turn it into a positive X, which means you introduce the negative number that causes the sign to turn around.
Okay, thank you.
For number 9, I got y is greater than or equal to 3.
Okay, so the 4 is untouched, but that's a 6, right? And 2 times negative 2 is negative 4y. And then this side's not going to change. All right. So again, you got 2 ways you can proceed. If you want to collect your X's on this side, I mean, your variables on the right side, you're not going to have to worry about that. But it could be slightly confusing because of the fact your X is going to be on the other side. So let's just go ahead and try to isolate on the left. All right, so that's 10 minus
Is it 3 greater than equal to y?
You mean the final answer? What did you, you're saying that I made a mistake? What are you saying? So this is going to turn that around because that number in front of the y, so that's y is greater than or equal to 3. Is that what you were saying?
Yes. I wrote it backwards. Do it matter?
Well, what do you say backwards? What do you mean? How are you going to be able to graph it or do the interval notation? That's the key. If you have 3 is less than or equal to y, that's the same thing. Okay? It is, but are you able to graph it like that? Or are you able to write the interval notation like that? As long as you're able to do that, then you're fine, because it's only one thing it's going to be. For example, this is greater than or equal to 3. So you have to get that part right. Or if we're dealing with a line, so then this is, as long as you're able to come up with those last two. Because like I said, if I had done it the backwards way here, if I had worked with the y's on the other side, I would have had 3 is less than or equal to y, which means the same thing. All right, what about that last one?
We got to multiply it. It's gonna be 3x minus 6.
Great. Minus 5x.
Mm-hmm.
And another 6 minus 6.
Mm-hmm.
And a negative times negative is a 2x.
Mm-hmm.
All right, so put anything together we can. Those two go together, so that's negative 3x minus 6. All right, and then I'm going to put them on the left-hand side. I think that's just slightly less confusing when you're dealing with an inequality. So that's why I'm trying to stick that. I did that one up there to show you that it doesn't matter ultimately. But you got to make sure you know what you're doing. So this is going to be 0. Now, if it's any number of x's, it doesn't matter if it's an equation or an inequality. When you divide by 0, you're going to get 0. So this is just x is greater than 0. So here's the interval notation. And then as far as, the line is concerned, parentheses, and then this could be 100 for all we care. It's just got to be in the right direction. And there we go. All right, any questions about any of those? All right, I'll give you a couple of minutes to think about that, and then I'll hit the next page. Probably be able to do half of that before we take a break.
I got the same thing.
Okay, great. Okay. All right, now this is 9.1. Don't get too upset because it's 6 chapters, 5 chapters ahead, 7 chapters ahead. All right. All right. Now we're looking at compound inequalities. All that simply means that you're going to have two inequalities that are connected by either an or an and. All right. So let's just look at this one. This is 2x minus 9 is greater than 7, or negative 2x is greater than or equal to 10. So what we're going to do is just we're going to work with them individually, and then I'll show you how to put them together. All right, so we're just going to add the 9 to get rid of the negative 9, and that gives us 2x is greater than 16. Divide by 2, no need to change anything around because there's no negative number introduced. X is greater than 8. Now, x is greater than 8 is going to be over here. That's on the positive side. 0 is somewhere in here. So it's greater than 8. So they're using this now that I've been showing you, the parentheses. They're not using the circle and the dot. And I would recommend that you start using these for the graphs. So this means x is greater than 8. On this one, you got to divide by negative 2. It changes from a greater than equal to a less than equal to. So x is less than or equal to negative 5. All right, that's this one down here. Less than negative 5 is all the way going towards negative infinity. This side is starting at 8, a little bit more than 8, and going all the way up to infinity. How can we graph that? Well, what these are, these don't touch. So what we do in order to write our interval notation is we put a U right there, and that essentially means or. This is kind of something if you take Math 120 next semester, we work with these things called unions, and that's what that means. Or and union mean the same thing, that we're tacking these two pieces together. This is that left-hand side, negative infinity to negative 5, including negative 5, unioned with greater than 8, all the way out to infinity. Questions about that one? All right, let's look at this next one. Now this one, it doesn't say or an and, but I'm kind of partial. They used to, I remember when I first started teaching this, they would always throw some ands in there. But I hardly ever see ands in the wild. They're usually like this, which is, it's a 3-part inequality. So this essentially means and just what it means is that 5x minus 9 is in between negative 4 and 11. So in order for us to find the endpoints that are a solution for x, what we do is we work on that inside, that middle one, and then what we do to the middle one to turn it into x, we do to the other side. All right. So on this, we're going to add a 9 to get rid of the negative 9. So that just gives us 5x. 11 plus 9 is 20. Negative 4 plus 9 is 5. Now all of those are divisible by 5. So this is going to be nice and neat. We got to turn the 5x into an x. So we divide by 5 here. And if we do it there, we got to do it here and here. Here it's 1. On the left, right, it's 4. 5 divided by 20 is 4. So what that means is that the value of x that solved this original thing, this original inequality, is between 1 and 4, inclusive, we'll say, because it's got equal signs there. And the good thing about the interval notation on this, it's real easy to do. You just start with the first number, 1, and you got a bracket there, comma, and then 4 bracket. All right. So take a look at these. I want to try to find one to replace this because they only have 2 of these. I want to get another one and I'll just replace that one. So y'all go ahead and start working on these and I'll be back in a minute after I find another one. Let's see. Okay, I got a good one.
Mr. Cruz, can't see the problem.
Okay. I'm going back. I forgot that I'm on that screen share. All right. I'll go back over there and write it down real quick and then I'll give it back. Just take 2 seconds. All right. All right. Already done. All right. Anybody got that first one yet?
Mr. Cruz.
Mm-hmm.
Okay, I'm kind of getting. Tell me if I'm reading it right, because I think that's why I'm having a problem when how to read it and put it with the the infinity. So is it -9, then the infinity?
No, because the infinities are all the way to the left. So you put that negative infinity all the way to the left, and
Okay,
the
so
positive infinity goes all the way to, is all the way to the right. Because
oh,
that's the farthest point you can get.
okay, okay. That'd be -3.
It sure is. All right. So
Okay, yeah,
again,
because that's the part I'm getting confused on how to write it with the infinity.
all right. Well, let's look at that. Let me just do this first. All right. So -9, let's say it's right here. And -3 would be right in here, let's say. We don't have to be perfect. We're just wanting to make sure we get it set up. Now, there's your parentheses that denotes -9 or less. And that means it's going down towards negative infinity. On this side, it starts at -3, and then it's going all the way up to infinity positive. So what we do is we put the u in the middle, and then this is a -3. This is a -9. Both of them are taking a parentheses. It doesn't look like a parenthesis, so let me do it again. Positive infinity on that side, because if you're going in that direction of that arrow, that's positive infinity. If you're going in the direction of that arrow, that's negative infinity.
Does it matter how you write the inequality?
What do you mean how you write it?
Because I got the answer, but I put negative infinity, then -9.
Well, what's that?
Oh wait, no. For the second one, I mean, I put positive infinity and -3. I wrote it backwards. Do it matter?
This?
Yes.
Well, I guarantee you, if you put it in my math lab like that, it'll mark it wrong. That's what I'll tell you, because positive infinity is not over this way. That's negative infinity. So how is anyone going to know whether you meant to put negative infinity there? The way that you keep it straight is you put the infinity on the side that it actually appears. The infinity that's on this side, on that left side, is negative infinity. So one might look at that and just think that you left off the negative sign. So
Okay.
that's not the same thing.
Okay.
So yeah, the side that you put it on very much matters. You put the infinity on the side where it is on the number line. On the right-hand side is the positive infinity. On the left-hand side is the negative infinity. All right, on this one, what do we got?
For that one, I got x is more than equal to 3. And
Yeah, it's going to
x
change
is
around.
less than -8.
So this is x is greater than or equal to 3, right?
Yeah,
Because see, it's less than, and then we introduce a negative number, so it's got to come around. This one is pretty simple because you're just multiplying by 2, the reciprocal. And so you multiply this by 2. So this is x is less than -8. Okay?
So for number 1, we didn't change the sign for the 4x one because we didn't multiply. We only used division.
No. Let me say this one more time. Division and multiplication are the same operation. Students somehow get in their head that because we're dividing by 4, that's somehow different from multiplication. But multiplication is division is multiplication by the reciprocal. So that's 4 being divided by 4, which is 4 times 1 4. It's the same thing. It's the introduction. I'm trying to talk. How do we check? Who is that? Okay. What causes the sign to go around is the negative multiplier. Because what happens is Let's see if I can get this back that I had. You see this? If you got 3 here, let's say you're at positive 3, and you multiply by a negative number, then that puts you down here. It swaps things around. That's what causes the things to flip-flop. It's the multiplication or division by a negative number, because those two operations are the same thing. Division is just multiplication by the reciprocal. Because if you got a positive number, you multiply it by a negative, then you're down here now. That's why that happens. All right, I was hoping we could finish this page, but my brain is tanking out before we get a break. Let's see. We might be able to do it. Still got 4 more problems. All right, let's take a short break, and then I need to kind of do something to get my head relaxed here. So I'm going to pause this. Okay, so I think some of them, they won't all ask you for the graph, but I think they're going to all ask you for the interval notation. But okay, so this is greater than or equal to 3. Or for the interval notation, negative infinity up to -8, but not including -8, u, and then 3 up to infinity. That's a terrible infinity sign. That's not an easy symbol to draw. It's just back an 8 kicked over, but
I just have a quick question, reference the order of writing it.
mhm.
Because I came up with the same answer, but I just wanted to make sure, because you know how you have the negative infinity and -8?
Mhm.
Basically, I switched that with the 3 and the infinity, putting them
You
on
mean
different spots.
I'm trying to visualize what you're telling me. You
So
had these swapped around,
yeah,
like
so basically mine's is the bracket 3, comma, infinity on the left side of the U.
yeah. I kind of think like they're not that.
Like I
My
have
math lab is not going to take
but
that, but I'm,
okay.
you can try it. But in other words, you got a mirror image of this, right?
Yeah, I basically have the same thing. It's just swapped on the other
Yeah.
side of the U.
Generally speaking, the thing is, these things are in order. See, you
Mhm.
start way down here at negative infinity, and then you get up to -9, and then you're joined together with something that's farther to the right, and then the infinity sign is even further to the right.
Okay, so just write it in the same as the
Yeah,
number.
it's
Okay.
sequential. It's sequential. So
Okay.
I think that's why that's important. I mean, if I saw that like on a handwritten test, I would say, pretty much get full
Same
credit
thing.
for it.
Yeah.
But I don't know if that, but this right here is technically where you should write it. And then I said in my math lab will recognize it.
Okay.
All right, as I said, is they only had 2 of these, so I replaced number 4 with one that I got. And so do this last one, and then we'll work on the what I like to call the 3-part equalities, which are essentially and. All right. And it's -5. This one's going to get multiplied by -3/2, which is going to cause a flip of the sign. So this is 6/1, -6/1. So -3/2 on both sides are reciprocal. So this is all just going to be 1x, but the sign gets changed there now because of this multiplier of a negative. Doesn't matter whether, it was divided by a negative or multiplied by a negative. It's just that because multiplication and division are really just inverse operations. They're the same operation for the most part. If you multiply by the reciprocal, you're dividing. And this is 9. Does that look good? Like I said, I'm getting tired out already, so my mind's starting to play tricks on me. All right, so this is so the u, and then this is greater than 9. No parentheses. I mean, it's a parentheses because there's no equal sign. This one is a bracket because that. And this is -infinity. And this thing is just like a number line, like I said, it's just that it's only showing you the important things on the number line, showing you the one that's furthest to the left, which is a -infinity, then going up to the -1, telling you that it includes -1. And this right here means it skips some stuff in between, anything between -1 all the way up to almost including 9. This means it's greater than 9 and going up to infinity. So these are a little bit more interesting. These are my favorite ones. I mean, of course, sometimes you don't get to choose what you do, but I like the 3 parts. But the same thing applies about the negative multiplier if you run into that.
How did you get 9? Did you multiply 3 times -3?
6 times -3/2. 6 times 1.5. 1.5. Half of 6 is 3. 6 and 3 is 9. See that? I multiplied by -3/2, which is 1.5 in disguise. I just did the multiplication by the reciprocal and, the negative sign. And that's what turned this from a less than to a greater than. So try number 4. We'll just try all 3 of them if you want. And then I'll come and start working on this with you. So you're still following those same order. So do the addition property first. In other words, you got that -1. So So these are gone, and so you got 2x less than or equal to 6. And that's 6 again equal 4, 3 plus 1. Then what? Divide everything by the number in front of the 2. The signs are going to stay the same because there's no negative number here. So what do we got? 4 divided by 2 is 6 divided by 2 is
Mr. Cruz, and why did you put all of them divided by 2 again and not 1?
where at?
You did all of them like 4 over 2?
Right.
2.
So what's the number in front of the x?
Oh, okay, 2.
Yeah,
Okay, gotcha.
2.
I'm sorry.
I'm doing the same thing, except I'm doing it for an additional part. I'm trying to make the center be x. So
Gotcha.
that determines what number I'm going to divide by. And so I got to do it on 2 sides now.
Okay.
So now these are a lot easier when it's talking about when you're talking about the interval notation. And actually for the graph too. See, both of these are brackets. And so the interval notation follows that same thing. You just don't, you have a comma in between it because it's just one section of the graph. Remember what we did over here when we were doing the ors is we had to use a U to tack 2 pieces together, but these, it just involves one line. All right, so how do we get rid of that -8 out of the center?
Add it on both sides.
All 3 sides now, though.
Yeah, all 3 sides.
Yeah, well, you're technically right. It is both sides because what we're doing here is we just are determining what number needs to be added to the other 2 sides. We know what's going to happen here. We're taking it out. So yeah, it's these 2 sides are what's important. So that's oops, it's not an equal sign. And then this is what is that? Let's see. -3, right? Here's that same thing I did here about the, to get rid of that, to counteract that 2x, I divided everything by 2. So here it's a 3, so I'm getting everything by 3. So what is it? What's that final thing look like?
The last part of it gonna be a 3.
Well, yeah, that's a 3. And this one is what? A -1, right?
Yeah, yeah.
So that means then this is what we got. Both parentheses. That's a parentheses 2. All right, try that last one. All right, so we got a -7, so very much similar to number 5. We're going to add the opposite to all the other sides, the other two sides. That one's gone, and we got 6x. 5 and 7 is 12, and 1 and 7 is 8. Now what? Divide everything by 6, right? And this one is going to be a fraction. It's going to stay as a fraction. Nothing wrong with that. And then 2 goes into 8 4 times, and into 6 3 times. So 4/3. Now, just for perspective's case, that's 1 1/4, right? I'm sorry, 1 1/3. Just so you know where to put it on the line app. Now, we don't really need to do the graph so much, but I just wanted to show you. Okay, so this is, it's a bracket. And then 2. All right. So we can just say if we had 1 and 2 here, 4/3 would be right about here. Because it's 1 1/3. So all right. Take a few more, a couple of minutes to look at that. Let me know you got any questions. That's pretty much it for those two. And I want to just look over one other little sheet. It's about, plotting points and getting familiar with what they call the XY grid. All right, anything last about that?
No.
Okay, so so basically 3.1 just deals with um, reading these graphs, and because when you got 2 dimensions, all right. So I think most people are probably familiar with this, but this is kind of the way it goes here. Let me get us a nice color here that'll stand out. This is what we call region Roman numeral 1 region. And then when I say that, I'm talking about this whole thing right here. This is where we've got positive values. And it goes in the opposite direction. It goes counterclockwise. And then this is negative positive. When I say that, well, first of all, let's go back to plus plus. That means that we go, that this value right here in the first position is the x. So we go in the x positive direction, if that's positive. And then positive up, if the y is positive, then it's up here. If the x is negative, the first term, because that's what this is, it's xy, then you're going in the negative direction when you're going this way down here. There's 0. And then positive is up here on the top. This one is number 3, Roman numeral 3. And this one is just the opposite of this one. This one is negative negative. See? -5, -4, -4, -5 are all over here. And then this last one is positive negative. The x is still positive, but it's the going down on the y-axis. So this is x, and this is y. The x is that horizontal axis. So that's the first thing that appears. So like, for example, on this, in order to get to this point right here, we go along the x-axis, and that's 5 on the x-axis. And on the y-axis, it's up 3. It's positive 3. Here, this one is down on the left side, so it's going to be -3. But the y is in the positive direction, and the positive direction is 1. See, like C, this is negative negative. It's -6, and then down negative, so that's 4, negative. D is on the axis. The y is the only thing that moves, so x is 0, and y is -3. Now, E is not moving anywhere. That's what we call 0, 0. That's the center of the universe. F, right there. To get to it, we got to go in the positive direction 4 times. And now negative 5 times. And then G is only on the x-axis as the only movement. It looks to be, that's actually 6.5. I'll just put 6.5 there. and then it's 0 on the y. So see how that works? Does that sound familiar for most people?
Yeah.
All right, so we just got to remember that, because if we're going to be graphing things, we got to be going in the right direction. And believe me, I make mistakes all the time, especially if I'm talking and doing this. Y'all have seen that, because you got to have a certain amount of concentration to make sure you do it right. So you got to focus. So let's see where this one right here would be. This is -1 in the x direction, down -2. See that one right there? That's B. I'm sorry, 8. -1, -2. This one, 9 and -2 and -4. So here's 2 in the x direction. The first one is always on the x. If it's positive, we go to the right. If it's negative, we go to the left. So 2. And then on the y, it's down 4, which is right here. So that's 9. Ten is positive, positive. So it's going to be up here, 1 up 2. Ten. This is going to be -x of 3. So 1, 2, 3, and then up 2. And you'll notice, see, this one was up 2. And so it's on the vertical, they're right on the same spot for the y. Well, it's 11. And then this one is just going to be no movement on the x, but down 6 on the y. And then this one's just going to be movement on the x. So it's 5. All right. Does that seem pretty clear?
Yeah.
All right. So let's go down to this one where we actually got a little cipher to do, as they say. All right. Now, if you've got an equation, now we did this already. We did this with some things. You remember we had to find out, given certain values, what L was equal to, and I can't remember what other variables we used, but that's what I told you when we did that last formula, that by far the most important equations to be able to solve for a variable are these right here. This is the similar to ones that you had seen, and then we solve for y. Now here's one that's solved for y. This is what we call standard form. This is what we called slope intercept form. Because if I've got it solved for y, I've got the slope and I've got the y-intercept. Now we're not quite getting into the graphing quite yet, because what we're going to do is we're just kind of going to be graphing by Platten points. We could easily find out where this line is at by going to -4, making a dot, rise and run 1 and 2 respectively, and that would give us another point, draw a line through it. And we'll eventually do that, but that's what that means. So what I want you to do here, like I said, this is kind of pretty much what we did a couple of sections ago. Remember, this is y. And this is x. So this is x, the first one. So this is x and y. So to find the other half of this point, then what we're doing is So if we do that, then what's the coordinate that goes there? I think it's going to be 2, but y'all check for me.
Yes, 2.
So the other coordinate goes right there, 2. Now you do it for this one.
Okay, so basically with this, we're solving the first one, which is solving for x.
And then this
And
one
the
is
second
solving
one for y.
for y, yes. And that's why we were doing those things over there. And that's why I told you, I said, this solving for formulas is pretty complicated. But if you can do like something like this and solve it for y to get these kind, you'll be fine. All those other ones, are not nearly so important. So let's see. So what happens? We got 3 times 3.
I got 4. That's the answer.
So this is 9.
I got -4.
Well, there's a difference. So let's see which one it is. Negative y is equal to -4. So what does that mean y is? Multiply by this by -1 and this by -1, you got 4. I know it's tempting to stop here, but that's not finished because we don't want to know what negative y is. We want to know what 1 positive y is. All right, now all of these are pretty much the same. It's just that they're in a different form. So go ahead and do this one. And this is when it's in this form right here, y is equal to mx plus b. Some of the calculations will be really simple. And you'll see them down here, but they don't. I thought they were going to show you on this one, but not. They're not. If x were 0, then it's going to be real simple because when you make a 0 here, that's all gone and you would just have -4. But that's not what they've got. They've got y is equal to 0. But we'll see some of those down here. So what happens on so 0 is equal to 1/2 x minus 4. So that means 4 is equal to 1/2 x. Multiply by 2. I'm trying to save room here. So x is equal to 8.
That's what I got.
Okay, good. So now you just got to remember this is x, and that's y. You can't mix them up. -4. So y is equal to -2 plus -4. Y is equal to -6. Double check and make sure, and then the little tables are a bit more useful in my opinion because of I don't know, that's just usually the way people do it, because when you're graphing using points, you can just pick certain ones, and there are certain ones that are going to be easier than others, and I'm going to show you on number 16. Was that -6, right?
Yeah, that's what I got.
Okay. So this is really the same thing as up there. They were just showing you up here in that kind of traditional ordered pair form. But try some of this. What happens when you put 0 in and multiply it times -3/4?
It's going to be 0.
That part will be 0. And what's left over?
It's just a 2.
Y is equal to 2. That's one of the most effective way to graph things using, is if you use 0, it essentially takes away a whole term for you and makes it a little bit easier to read, and rather than having to go through and multiply everything by something. So oftentimes when you're picking points, 0, if it's in this form, especially 0 for X is going to be very helpful because it's going to make that whole thing go away. And whatever's left is your answer. Y is equal to 2. Because 0 times -3/4 is 0. Y is equal to 2. There's really only these two. This right here and 20 are kind of special cases. So what happens when you put in -4 for Y? You got -4 is equal to -3/4 X plus 2. So -2 minus 2. So that's -6. Now, since both sides are negative, if you multiply both sides by negative, we got, I'm just going to turn them around. Since both of them are negative, then they're both going to be positive when you multiply each by that negative sign. So that's all 1. So X is equal to 3, goes into there twice, 8. Now, when you multiply -3/4 by 1, well, you just left with -3/4. So -3/4 is just a little bit less than 1. So basically we got 4, I think it's 5/4. Hold on a second. Yeah, that's right.
Yeah.
So if you take 2, it's 8/4. In other words, 2 is 8/4 minus 3 gives you 5/4. Now, as I said, this 17, it's called the standard form. And I really wish they had picked a 0. Oh, but they're going to do it down here. So this is not that important. But the standard form, you can almost get 2 free points because, okay, if you let X be equal to 0, then this whole thing is gone and you just got Y is equal to 4 left. And the same thing, if there had been a 0, if they had wanted a 0 for Y, then that would be gone and you'd have 4x equal 4, which is X is equal to 1. But they don't pick that, so.
I'm kind of confused. Can you work this one out?
What do you mean work what out?
Number 17, can you do this one?
Okay, let me just do this. If that's 0, then what's left over? What's left over there on the right? Y is equal to?
4.
Yeah, there's nothing really to work out. That's the whole thing. Because anytime you introduce a multiplier of 0, that whole term goes away. What's 4 times a 0? I mean, you can write it out there, but it's going to look awful strange. So because you don't usually write zeros. Just Y is equal to 4 is all that's left. And in a minute, these you're going to see these are going to be really strange because there's no work at all. You just got to understand the special case. It's sort of like you know, anything 0 divided by anything is 0, or anything divided by 0 is undefined. It's just the special cases, and they do relate back to this. Okay, and I was doing this one.
So you just plugging in
Yeah, that's what that is. X and Y.
to get the other side.
If
Okay.
0, if X is 0, then 4 times X is 0, and all that's left is Y is equal to 4. This one is Y is equal to -1. So that's just placing that. Now this has got something to do. We can actually show you something here. So +1. So this is 4X is equal to 5. So X is equal to 5/4.
I get it now. Thank you.
Okay, good. Yeah, I mean, I said it's so simple because it's essentially a free point, because it makes that whole term where the X is gone. And then it's going to happen again here, except it's going to happen twice on number 18. And now this one, it's 4 times -4. Like I said, this one you have to work out because there's some things going on there. So this is -16 plus Y is equal to 4. And then when you plus 16, you got Y is equal to 20. All right. So 3 is like the last one where there's really any work to do. And really, there's only work to do in one situation, and it's this one down here. Okay? All right, if X is 0, and like I said, I can write this out, but it's almost kind of meaningless to do it. 3 times 0 minus 4Y. Well, what that does is it just makes that go away. And you got -4Y is equal to 12. And Y is equal to -3. You essentially get almost a free point because you're doing away with one whole term. Now on this one, it's the Y, so it's going to be 3X. See, that's gone because of it being 0. Then all you got left is 3X is equal to 12. Or X is equal to 4. All right, now this one is going to take some working out. So X is 8. So we replace the X with 8. So this is 24, right? So we're going to subtract 24. I'm sorry about this room. Let's see. I'll just go across here. So it's -4. Y is equal to 12. I'm sorry. I can't go out that far. Right there. So this is -24. To get rid of that positive 24. And then this is 12 minus 24. So what we have left is -4Y is equal to -12. or y is equal to 3. So that's a 3 there. All right, so I'm just going to have to show you the line at each one of these. This is kind of strange. Like I said, it's there's nothing really to show. So I'm going to show you a graph and calculator to show you what that line looks like. Y is equal to -4. Okay, so can you see where that line is at?
Yeah.
So that's y is equal to -4. So what that essentially means is if x were 0, then y is equal to -4. If x is 2, then y is equal to -4. If 6, if x is 6, y is equal to 4. In other words, we don't even have an x term in there because no matter what it is, y is equal to -4. Y is always equal to -4 in this case because that's what it says. Y is equal to -4. So going back over here, you can put in any points you want. Doesn't matter what they are. Oops, I'm sorry. No, back up. They've already got the difference. So this is always -4. There we go. No matter what x is, y is always -4. Now the same thing is going to happen with this. It's just going to be the opposite. So this one is -5 all the way down. And I'm going to graph it for you in a second, just so you can see the difference in the two lines. So I'm going to also, all right, there's the graph for x is equal to -5. See, there's -5 right there. No matter what y is, x is always equal to -5. So that's why I just filled in -5 along there, because x is always equal to -5. It tells us right there, x is equal to -5. No matter what y is, x is equal to -5. And its counterpart, which was y is equal to -4, well, it doesn't matter what x is, y is always equal to -4. So there's no calculations to do on those at all. Just kind of show you by graphing how it works. All right, so any last questions?
No.
Okay, so I did show you this